Hey, all right, everybody. So welcome to week 7. This is the first set of lectures for this week, and I'm back in town. We were just up in Browning last week. I'm just going to show you a little bit of what we did there. I have another conference coming up next week, so I'll be here for the 2 lectures. This current week, I will not be in the lecture hall during week 8. So you got me these next 2 days, but I got to be in Washington, D.C., so I'll pop out a couple videos from there. But while we're talking about what we did last week, I want to show you some of the beauty of recycling technology, and then we'll get into the forum and then into the course. So I've got this stored under my grants. As you may know, in 2013 we were awarded a $750,000 grant from the National Science Foundation, and part of that involves going to a conference, and that's coming up this fall, and here it is. And I've got a couple photos. And that's kind of the one I was looking for. So this solar thermal technology was actually built with recycled cans. So we're talking about metals, and each one of these little black cylinders that you see here is just a aluminum can. Now, going back to sort of the fundamental philosophy of recycling technology, you've got sort of your 2 broad categories. One is your materials, obviously metal, aluminum being one, and then you've got your artifact, right? So you can take aluminum and turn it into an infinite number of things. One of them is a soda can. Now, once that soda can has served its purpose of providing you with a beverage, you now have the responsibility to do something with it. A lot of times these end up in the landfill, unfortunately. Sometimes they go back into the aluminum can recycling stream, thus leaving virgin materials in the ground for future generations. Or you could repurpose it. So we took that artifact, that soda can, and turned it into a value-added artifact. We turn it into a heat exchanger. So at the bottom and top of each one of these soda cans is about a 3/4 inch hole. What that hole allows the technology to do is to sort of keep the air inside the can a little bit longer so that it heats up more and then is blown out. What you can maybe just make out, this is the air intake at the bottom. It's just going through the 4-foot wall near the colder, lower levels of the room. You've got some natural convection happening here, so heat rises. A hotter molecule is always going to bounce around and sort of shove the colder molecules down. The hot one's going to go up. We've also supplemented that with a fan. In this top intake, there's a little fan that's driven by the solar panel and does a little bit of forced convection. So there's an example of using metals, actually aluminum cans that might otherwise go in the landfill or the recycling stream, and really adding a lot of value to them. So that's where I was last week with Tim Chester and a few other folks. This is the house. It's currently under construction. It's facing east at the moment, but as soon as it's turned, it'll be facing south, which is the direction we're sort of looking off into the sky there. Okay, so that was last week's recycling technology adventure for me. Now let's get into the shell. I'll turn the editing on, and I want to go ahead and highlight week 7 metals. And I don't have anything posted here, but I thought I would just start today's lecture by showing, hey, that's an example of something that you can do with recycled metals. So before we get any deeper into that, though, I want to just sort of catch up on some old posts. I want to catch up on glass. There was one student who emailed me and said, hey, I didn't get a chance to take quiz 4. Can you reopen it? I did. So if there's anybody else out there that didn't get a chance to take quiz 4, it's now reopened and you can hit that. So let's just catch up a little bit on the glass forum, and then we'll get into metals for this week.
Some of them are pretty good. More good than bad.
Okay, so I guess this is just an example of a glass technology. I'm not. Is there a recycling component here, though? Maybe I'm not seeing. Any more pictures? Okay. Anyway, I don't see. Oh no, I'm sorry. Here's the glass temple. Oh yeah, there it is. Duh. So I guess this is just a photo, and I don't see any other kind of close-ups, but apparently this is an example of an actual building that was made from reclaimed glass. There's another book out there, and in fact, I just emailed the authors, and this was just a little bit of a fascination with me, but there's a Bathrooms of the World. Yeah, I've had this website going since '95. And there's a book out there, Toilets of the World. Here it is. And in this particular book, there's another example of a famous architect who repurposed glass bottles to make sort of a translucent wall. So, obviously you're in the bathroom, you want some privacy, but you'd still like some light. So he just used glass bottles, really in a similar way to what we just saw with the temple, to sort of let some ambient light in and use the glass as a structural component. Obviously, with something like this, either some. Oh, is there another one up top? Oh, there we go. Oh yeah, I've seen this one. Yeah. With something like this, I just want to make the disclaimer before you get too anxious and into building your own. You might want to consult with an actual structural engineer. I don't know what else is going on inside this building. If maybe they got some steel, some concrete holding it up, but every material has its limit in terms of structure, in terms of what kind of loads it can bear. And as beautiful as this is, it would be a shame if, for example, just a number 2 earthquake came through and took it out. So we're just catching up on the forums from the last couple of weeks since I wasn't here. Candles, jars, soldering them together. Okay, so stained glass, that's another one. So you might have broken fragments. The things we've been looking up to this point were, full, intact cans and bottles. In this case, though, you've just got little pieces and then sort of reassembling them into a new building or a new stained glass project. Some greenhouses, West Virginia, old-timers, repurposing. And then just last week, I tasked Maria, she was kind of looking for a project. I tasked her with doing some of the construction for the glass wine bottle water catchment that that I showed a couple weeks ago. So hopefully we can move forward on that. Thanks for that post there, Tynan. I like it. Rachel, food preservation, candle holders, plant recipes and jars. I like that one too. Yeah. One thing I really like about those mason jars is just the way the lids are designed. They're not a one-time shot like you'd see on the cap of a spaghetti bottle. They've got the vacuum seal, and they're standardized. They're interchangeable. So Yeah, I'm a big fan of the mason jar as well, or the ball jar, sometimes they're called. Home structures. Yeah, MCFU is a great one. The last time I was over there, you take a really close look and you can still sort of see the like the little Sprite logo or whatever. You can actually see the imprint. So there's very little processing going on. One thing though I want to warn you against in terms of glass repurposing. I was at a house not too long ago, and some gentlemen were having some photovoltaics put on their roof, and they were really trying to do the right thing with glass. They realized that it's inert. If it's just sort of laying out there in your backyard, it's not going to contaminate the soil. They decided to repurpose some pulverized glass for the walkway coming into their house. Well, glass is really just little rocks, little stones, little pieces of silica, and as well pulverized as it was, there was still just enough kind of sharp edges that you get a little piece of glass in the bottom of your rubber shoe, and now your rubber shoe brings that into the house, and now you're sort of grinding away the finish on the nice wood floors they had. So that was, an issue where maybe the glass repurposing for a pathway was not the best choice for this particular household with the wooden floors. But yeah.
Was that Canty's?
It's on a street called Longwood. I can't remember the name of the owners.
Yeah.
Neat looking place, but they were kind of regretting the fact that they had all these glass shards kind of being dragged in and out of the house.
Yeah, it was real pretty, but every time you walked past the walk, you dragged it either into the house or back into the street sidewalk area.
Yeah.
It did follow you.
Yeah. I mean, it could be that maybe a better selection would have been to embed that glass in a concrete, so you still get that. You still have the materials there. You get the visual effect, but you're not dragging it all over the place. Yeah, like the glass countertops. Quite a few examples. Metal rebar through the bottles. How do you, I guess I'm reading this here, how do you run the metal rebar through the bottles? Maybe, let's just take a look here. Oh, another thing on this, guys. When you post a big, long URL, if after you've pasted it in there, if you put like a punctuation or a space after it, the code in here should turn into an actual link. I don't know if you guys have done that before, and I can show you what I'm talking about. But let's just say I'm in a document. I'm just going to do it in Microsoft Word, but it works the same. Actually, I'll do it this way. URL protocol. Let's see if we can't get a URL to act as a link. For example, I'll type in my own, let's just do it this way, http://www.humanpoweredfuture.com. Maybe not. Let's just see.
There's power links on top too. I think it's a control.
Oh, is there another way to do it?
There's a hotkey. I can't remember. It's Control L.
Oh, maybe it's Control K. Try again. www.humanpoweredfuture.com.
One of the hotkeys is control something little hot link.
Oh, is it use Advanced Editor? Let's try that. Oh, here we go. Yeah. Yeah, let's try this. Human power future. Link. Okay, here we go. So now this is the URL. Link URL. Layton's website. Class. Search. Okay. Cool. Okay, now let's see if that worked. Post to forum. Okay, there we go. So I went into the advanced editor. So all I'm doing here on Sam's post is just saying you can put this in as an active link. It'll do other people a favor of being able to click on it. But nevertheless, let's just take a look here. See if I can't put that into a new. Yeah, so that's a problem. Unfortunately, it didn't end up working. So anyway, in the future, when posting these long that one might work. Okay, that one worked. Right. Oh, I see. So maybe that's your rebar. Yeah, I guess the question is whether maybe maybe there's a hole there, and I don't know. Is this some kind of rubber gasket or some kind of
Like a racquetball or something.
Yeah. So it looks like they're putting some kind of gasket or a tennis ball or maybe a racquetball in place.
So it's more aesthetics.
Yeah. Neat. Okay. Well, thanks for that post. I like that. And again, here, there's the case where you're gonna want to be careful and make sure you've got your engineering dialed in, so you're not risking. Beth, curious, new construction, home with energy tax Raymond last summer. Yeah, I think that is. Yes, Beth. Joe, that's correct. Beth's new home is on Raymond. Submit. Okay, perfect. All right, so we caught up on glass recycling. Let's do one more last week's forum, and then we'll get into metals for this week. Cellulosic Materials. Oh, hempcrete, nice. Okay, I hear more and more about hempcrete all the time.
Pretty interesting.
Yeah.
Why is that?
Well, it's so in just let me show you a couple things just structurally that would be very handy to know in general about structural mechanics. So if I've got a chunk of material sitting here, we all know that we can put on a compressive load like this. So I'm going to put force compressive. You can also put on a tensile load, force tensile. So you can imagine, squishing this thing from the top and bottom and sort of pulling it apart from the sides, if you will. Now, thinking back to the glass bottle structures that we just saw, obviously, the higher and higher you stack those bottles, the greater and greater these compressive forces become until the thing actually cracks, right? Same thing if we were to put something in tension, and typically structures like ropes are designed to be put in tension. The harder and harder you pull it, the more likely it is to crack. Now, if I'm pushing in compression, what I'm going to get is some kind of crack like this that happens at a 45-degree angle. If you go out and look at any old building, you're going to see these cracks sort of running along in this direction. Like, well, how the heck did that happen? Well, gravity's pushing the thing down. This thing wants to slide this direction. This thing wants to slide that direction. And that's how things fail in compression. Concrete is designed to support loads in compression. But every material has its limit. Now, the tensile load, on the other hand, just imagine now, instead of just pure concrete, you've got little, and I'll draw a different color here. Let me just find something. You've got little fibers. So this end, this right end of this fiber is stuck in the right half of the concrete. This end is stuck in the left half, et cetera, et cetera. You could think of these as being rebar or whatever. You might have gone to the hardware store and seen polymer reinforced concrete, for example. And all it is, there's just a bunch of little fibers in there. Now, you could also, instead of using polymers or rebar, you could use another naturally occurring fiber, and the hemp plant is notorious for having extraordinarily high tensile strength. We spent a lot of time talking about cellulose last time, and I think that's where we're going with this cellulose-based discussion. Cellulose is at its fundamental level, as we saw last time, just a bunch of glucose molecules that turn into starch, and then ultimately turn into cellulose and hemicellulose. They're very different and diverse depending on what organism you're talking about. Nevertheless, you can see that as this compressive load is trying to push the thing together, these little tensile structures, being either polymer fibers, rebar, or, as we're just mentioning here, hemp fibers, hold it together, right? So that's sort of what's going on, in general in a structural material, and so hemp has been looked at in terms of its durability, longevity, and its extraordinarily high tensile strength. So does that answer your question? It's just the natural occurring fibers from the hemp plant. Okay, lifespan of the wall, two-story building. There you go, shear strength. So Sean mentions shear strength. What do I mean by shear strength? Well, it's the strength that keeps this big black crack from opening up anymore. Because what's happening is in fact shear is occurring, and that's exactly what these two arrows are showing. Is that these two things are slipping past each other, just like this. They're shearing apart. The other fundamental modes of loading are compression, like we just said, tension, pulling apart, and then finally bending, which in fact is just a combination of tension and compression. It's something that's being put in a bending load is being pulled apart at the top and pushed together at the bottom. So you might also say, well, what about torsion? Well, twisting something apart, that's just another version of shear, where things are sort of sliding past each other. Okay. So there's your little structural engineering materials science lesson for the day. Absorbance 2, great product. Lack of chemicals naturally occurring, more enjoyable to work with. Foundation, top coat. Yeah, and I haven't seen any formal studies on it, but I think especially with the changes we're seeing in I can't imagine that there's not more hemp coming out of like Washington and states like Colorado now, where they've got to do something with that product. So could see a revival there.
There's places in Europe have been doing it for over 200 years.
Yeah.
Fortunately, United States laws make it difficult to deal with hemp.
Right. Well, I'm in a similar situation right now with state laws in California that won't allow the combustion of some of their nut products. So, there's some cellulose in the outer hulls of nuts, and it looks like we might get a contract here pretty soon to turn some of that into biochar. Take that and turn it back into an agricultural product. All right, so thanks for that on the cellulose forum. Hey, and also, everybody, thanks a lot for stepping up on the forum. This is really what makes the class cruise along. Straw bales for the walls. Funny you mentioned this, that same house that I showed you with the solar thermal heater, they had some straw bales there, wondering what to do with them, and we were looking at using them for insulation around the base. Now, the one thing you've got to be careful about, our very own Flat, the Sustainable Living Center here for undergraduate students, use some straw bales. They got to stay dry. If they get wet, you've got mold issues, stinky, health things. Nobody, so it's critical that these things stay dry. And again, straw obviously made of cellulose. Also, you got to be careful in terms of structural engineering. These things get too high, and you've got issues for collapse going on. So I like the cellulose discussion so far. Okay, yeah, I like this. So Joe's saying their go-to insulation material was cellulose. There's your newspaper, again, cellulose. And and I hope we get there eventually, that we're not actually having to ship in shredded cellulose from Salt Lake. Now, and the challenge here is just having a sufficient space, and a lot of times this just comes down to economics. Enough space to store the newspaper so that you can then shred it and keep that product local. So I think if we can get our act together here in Missoula, I know we make enough waste newspaper that we could have our own little cellulose industry. In fact, I was looking at this through our Department of Labor grant a couple of years ago, and I was surprised, but the Board of Regents were not really impressed with the whole notion of recycling as a economic base. But maybe we'll get there someday. Now, this one I'm curious about, Joe. If you've got a paper to back this up, it says cellulose typically increases energy efficiency up to 30% over fiberglass insulation. So there's a couple factors to consider there. One is, what's the actual R value? And it's going to be an R value on an inch by inch basis. So I guess I'll just challenge you a little bit on that, Joe. And if you can show me a paper or a reference on that, I'd love to see it. It also depends on how well it's packed. We had a similar issue installing that solar thermal technology in Browning. We went with fiberglass specifically because it's got a much higher combustion temperature. We were worried about putting cellulose in. These things get so hot. You do not want your newspaper to spontaneously combust. We had the same problem with plastics with a melting temperature right around the boiling temperature of water, which is how hot these things get. So we went with the fiberglass just for the thermal properties, for the combustion properties. So a lot of things to consider there.
I've heard of the same kind of thing done with like recycled jeans.
I've heard that too. Yeah, jeans, which is usually a cotton product, and the cotton structure, I would have to look into that specifically. I'm thinking, cotton itself, I'm sure there's some cellulosic structure in there, but not just, regular old cellulose. It's more of a specific molecule. Dense pack, taller walls. So the dense pack that he's talking about, that's actually going in and spraying in cellulose in a wet form. And so it's a way that you don't really have gravity in your favor blowing it in an attic, so you're sort of spraying against the wall. And that's going to have its own R value probably a little bit lower because you don't have that airspace in, but sort of to interrupt the heat transfer. Well, that's great. It sounds like Joe's getting some nice hands-on experience with cellulose as an insulating material. Okay. Bamboo fuel, fluorine, ethanol, ethanol. Yeah. So in the case of, in this case, the bamboo, this, I'm guessing this is going through some kind of biochemical reaction, right? Where yeah, so it's a fermentation process. So we're relying on the enzymes in probably a yeast or some related organism to actually make the ethanol as a waste product.
I can put the specifics on there if you'd like. I think they use some type of acid to break it down, and then,
Yeah. I like that. Man, I don't know if you guys heard in the news today, but they're having some big problems in Indonesia with these palm oil farms, and they're actually like setting peat bogs on fire to clear them. It was just the most bizarre thing I ever heard, but apparently these billows, the smoke is billowing out of Indonesia and like causing people to have to stay indoors and Malaysia and all this. It's just bizarre to me that you would actually set peat on fire knowing what a valuable resource it is for agriculture, but man, I just couldn't believe it when I heard it.
same thing as burning rainforests for cattle.
Yeah, exactly. Burning virgin rainforest for agriculture. It's just bizarre to me that type of stuff still is happening on this planet. Okay. Here's another one from Sean. Bioethanol. Yeah, I agree. I don't think we're doing this the right way. If you caught my Billings talk from a couple weeks ago, I more or less said the same thing. There was a paper in the Proceedings of the National Academy of Sciences in 2006 from Hill that said, not only is the energy return on energy investment sometimes barely above 1, it's sometimes negative. You're just throwing good money after bad. Yeah, and I have seen a lot of good stuff out of some algae companies, and I think that's a much more sustainable, eco-friendly, if you will, non-conventional way to go about processing biofuels rather than corn. And I'm also not a fan of having energy technologies competing with food crops. We're actually feeding things to our machines that we should be eating ourselves. It's just
Majority of the corn grown in the United States is actually inedible because it's designed to make high fructose corn syrup inedible.
Oh, really? Huh. So it's actually genetically engineered in order just to go into fuel and food additives, more or less. You would never actually.
A lot of farmers that grow it can't even use it to feed themselves.
Yeah, I could see that. Yeah. Well, that's a whole GMO question too. Loose fill, fiberglass. Yeah, I've seen this too. The one thing, the one thing that's critical. We talked a little bit about fire safety. Is that you have enough fire retardant in that material so that your cellulose does not burn. One thing that I've been looking towards is taking the gypsum. So if you drywall, so typically drywall, a lot of that gypsum is actually the waste product from coal-fired power plants. It's just ash. I mean, it has had its chance to burn, and it is gone through the belly of the beast, and it is not going to catch on fire. So, and anytime you see a remodeling project, I could really see a really good use of using a critical fraction of that gypsum, that drywall, mix that in with the cellulose, and now you've got a renewable, sustainable, zero landfill product for insulation. Another big thing too, we talked about mold a little bit, is that it's got to be cleaned in some way. Maybe it's heated through a process that kills the microorganisms in there. Because there was a remodel being done on my street, and I saw all the old cellulose being sucked out of the walls in these giant bags, and they were on their way to the landfill. But man, what a great resource to mix with newspapers, to mix with some old gypsum. Also, it was coming out of that building, and turn it into a nice, big, great insulation product. So, Rachel, thanks for that post.
That's one cool thing I found about the hempcrete as far as molds.
Mhm.
The hempcrete breathes.
Yeah.
It's actually resistant to molds.
Oh, really? Okay.
Because when the humidity level goes up, it'll absorb it.
Mm-hmm.
And when it goes back down, it'll release it.
Yeah, and it's not that surprising. So what you're mentioning is the fact that the hempcrete will actually breathe in the microstructure of individual plants. I mean, you've got your xylem and your phloem. You've got the little tubes, and if those remain intact, I could see those as being little breathing structures, sort of moisture control, if you will. There's even slightly off topic, but there's another concrete that was just invented by I want to say the guy is Dutch, but he has invented a self-healing concrete. I don't know if you heard of this or not, but the concrete is mixed with a bacteria inside it, and that bacteria is sort of constantly eating its way through the concrete and leaving behind sort of a calcium carbonate residue behind it, in a very similar way that our own bones are constantly consuming and redepositing themselves. So, yeah, there's some cool stuff going on in the building trades. Okay.
Concrete that will actually allow water to go through it, like almost absorbs water.
Yeah, well, in fact, there's enough water in this concrete that's been engineered so the microorganisms can metabolize that water. Yeah, absolutely. Yeah. Okay, so I think we're all caught up on the forums. We're going to take a little break here and then get as far as we can into the metals.